So in continuation to our previous video, in this video we will discuss trioxides of group 16 and the general formula of trioxide is EO3. So for ozone, O3 and SO3, these are gases, and all compound, like all the elements of group 16 form trioxide of EO3 type. So now the structure of sulfur trioxide. Sulfur dioxide we have already done, and in case of sulfur dioxide, what was there? The ground state electronic configuration of sulfur was 3s2 and 3p4. For the first excited state, one of the electrons from p orbital that is excited to the d orbital. In this way, as a result, we were having there two type of pi bond. One was p pi and other was d pi bond, and sp2 hybridization was there. Now what will happen in case of SO3? We will have a second excited state. That means now this electron, this will also shift to d orbital. That means it will get excited to the d orbital. And now let me make that. So sulfur in second excited state. So here we will have, this is s orbital, then p orbital, and then d orbital, in this way. Okay, so here there will be, no, because it is in second excited state, so now one electron from this will also move on to a higher energy level, that is the d orbital. So in this way we will get unpaired electrons. Okay, now this will be, because in SO3 also we are having 3 oxygen atoms. So what is there? The structure is somewhat like this, SO3. Okay, so now no lone pair is there, so that means this electron is getting excited to the higher energy level. So now the hybridization, this was S, so sp2 hybridization, so that 3 single bonds can be formed with oxygen, with 3 oxygen atoms. So 3 oxygen atoms are there, so there should be like 3 SO bond, and these bonds will be sigma bonds. Okay, so remember, hybridized orbital, they will always form sigma bond. Okay, so now just have a look here, like in this case this will be sigma, one of these, anyone, so one will be sigma bond. Now this is unhybridized and these two are unhybridized. This is p orbital and this is d orbital. Okay, so this p orbital will form pi bond with p orbital of oxygen, and that will be p pi bond. So that will be p pi bond. So out of these, that means anyone we can take. So p pi bond. So suppose like if this one is p pi bond. Okay, so now these two unhybridized d orbitals, they will overlap with p orbitals of oxygen. Okay, and again we will have d pi p pi bond, and how many bonds will be there? 2, with 2 oxygen atom. So 2 bonds with 2 oxygen atom. So now just have a look here. This one was p pi bond, so this can be p pi d pi, and this can be p pi d pi, where d orbital is of sulfur, and p orbitals are of oxygen. So two type of pi bonding is there. One is p pi and another is p pi d pi bond in case of sulfur trioxide. Now because of resonance here, what will be there, again the bond length will be same. So three resonating structures will be there and we can show in this way. So again double bond here, double bonded oxygen, then double bonded oxygen, 3 oxygen atoms we need, and then the resonance hybrid where we show it in this way, okay. So now not this one, okay, this, it will be like this. I will make it again. So it will be sulfur oxygen. So this shows double bond, this shows double bond, this shows double bond, okay. So now out of this, because we represented this one as p pi bond, now we can take another one. So if this one is p pi bond, so this will be p pi d pi and this will be p pi d pi. Then shift this p pi in the next resonating structure towards this side with this oxygen atom. So it will be p pi and this will be p pi d pi bond, okay, in this way. Now because of resonance, what is there, the bond lengths are equal. So like it is 142 picometers in all this, and bond angle is 120 degree here. The molecules like of SO3 are held by weak van der Waals forces. Because of these forces, like because of weak van der Waals forces of attraction, SO3 molecule exists as gas at room temperature. However, if we look for the solid state, so in case of solid state, again it is having linear polymeric chain. So here what is there, we have such type of structure, sulfur here. So in this way we have oxygen, then sulfur, 2 oxygen atom in this way, again oxygen, sulfur, oxygen, and in this way. So in solid state there is linear polymeric chain, and in case of gaseous form it exists as a the triangular planar structure is there. So it exists in this form,